we have to wait for the file to be complete before we can replicate it. So if we have disaster recovery enabled, as soon as the file is written to disk, we can replicate it. And you can see that literally minutes after the head, so maybe 1, 2, 3 minutes after the event occur, we have a backup already of that data. Now, that backup may be on a local drive, or it can be, obviously we don't write directly to tape. We stage data before writing it to tape, but it can be replicated to another location and then moved to tape. As we go back in time and the local disk space fills up, we have the ability to move data to another tier of storage. So this could be block storage that is local in the recording server. This could be NAS storage or object storage that is either local in the facility, or it could be in a remote facility. And then obviously when we can play this in real time, so that's not a problem. And when the data actually goes to tape, then we have the ability to synthesize camera data, because this cannot play in real time. You know, this data is stored on tape, it's available, it's retrievable, and that's what one of the beauty of tape is that it's cost effective. I guess the side effect is that you have to wait to retrieve that data. And the whole question is, how do you retrieve this data? And if I zoom in here a little bit, and let's say I need to retrieve some data, all I have to do here is select a time range that I need to retrieve data and create a job. That's what I'm being told to do. So create a job, select whichever camera that I need to access, add those camera to a list of submit task, and then submit the job. So once I submit the job, it's going to take a few minutes to get to the data and all that. So while we do this, and we're just going to trigger this, there we go, job's been submitted. So again, in terms of triggering the retrieval, this is how it works. Now we take care in the back end, and we'll go to the tape control in a second, but we basically take care of managing the tape, which means all the formatting, mirroring, recycling, drive cleaning is all taking place in the back end. It's fully scalable, so we can manage petabytes of data. We work with HPE for their library, and essentially provides a range of different options we'll cover in a few minutes. And it's a very cost-effective solution. So the setup typical setup with tape would be to, instead of, I mean, if you have a single recording server, you can go straight to tape. But if you have multiple recording servers, there's a number of options. One option is to set up a head server that will control the tape library, and essentially from the different recording servers, write to the head server. One of the beauty of our technology is that Surveillance Bridge can take the data that is on the block level storage here and move it to an SMB share from the head server, even if the VMS doesn't support SMB shares. So we can do that. This essentially lets us stage the data to a local server. And the idea of staging the data is to be more efficient when we're writing to tape, so that we can actually write a complete tape or part of a tape. But the idea is to accumulate some amount of data here, and we can schedule and trigger and say, okay, we can either write to tape at least once a day. So even if we're not going to fill up an entire tape, maybe we do that once a day, a couple of hours or a couple of days. So all that can be configured. And when data get written, in this case, to a landing zone, so the landing zone can be any size. So it could be large enough to hold everything we want to play back in real time before putting to tape. Or if it's too small, we can also use another tier of storage. So we could go to an object store, to a NAS, something like this, and also to tape. So we can actually write 2 copies, one copy to the immediate tier that can play back in real time, and we can set a policy to delete this after a certain amount of time. So imagine we have a 6 months or 1 year retention. Maybe we only need to keep 30 days here and 1 year here. So The first 30 days, we're going to play back directly from the local tier. And then after 30 days, that data is going to be deleted automatically, but it still be available from tape. So then we can retrieve from tape. Another possibility is to set up a high availability solution with 2 servers. In this case, essentially we're using, there's one active server that's going to receive the data, set it, stage it, dump it to tape, etc. But if there was ever a failure of this recording process, it automatically switches to a secondary server which can continue the job. So it's a very robust solution that can scale to thousands of cameras, etc. So let's take a look just here. That's done. So our retrieval is complete, and we should be able to, there we go. Our data is right here. Play the data. So now that the retrieval is accessible in the VMS, as you can see, I had nothing to do, just wait for the data to be available. And once the data is available, it comes back directly on the timeline. I don't need a special tool to play it back. It goes straight on the timeline. Again, right now I'm using Milestone. In Milestone, we can see the color code. In other VMS, most other VMS, we currently don't support that, but it's the same thing. You don't need the colors to play it. You just play the timeline. So that's how it works. In terms of the UI for managing the tape, well, let's go there. So there's a number of comprehensive options. So first of all, it works by creating a bucket. That bucket can have, so there's data coming inside this bucket. That's data that is being staged. If I look inside of this bucket, I can actually see let's say to any stage file. So I can see the files that are coming in that are being staged. I can assign drives, physical drives. So if I have multiple drive to my tape library, I can have multiple drives. I have 2 drives here, so I could assign both drive to this particular bucket. I can assign tapes as well. So I can have multiple tapes and I can keep adding tapes to this particular bucket. And so essentially each of my bucket can have different configuration, different data set, etc. And once the data's been staged, I can configure all the writing options as to when to write the data, restore it, etc. So those are kind of the control that we have to manage the tape library. In terms of the libraries themselves, HP offers, let's say the 3 main libraries that are available from HP. There's a small form factor, a 2U, which for typical deployment, you can think of this as being good for like approximately 100 streams of camera, and we're talking HD resolution. So typical HD resolution, 12 frames per second, 40% motion detection. So 100 stream of cameras, you could store up to 1 year of recording on a small 24 slot library with two tape drives. The MSL 3040 is a much bigger and scalable tape library, so you can actually add additional units with to store tapes and tape drives. So it actually scales from 30 slots to 640 slots. And just to give you an idea, that's enough for like 1,500 cameras to store 5 years of data. Or if you have 10 or 15,000 cameras, you could store up to 6 months on this solution. This one is also a library we support. It's just not as actively promoted right now, but similar type of content. So we can help you and the integrators figure out how many tapes am I going to need, what type of library, how many tape drives, how many, because the number of tape drives is critical because it depends on how many streams are coming in, and those calculations can be pretty complex. So we have a good calculator that allows us to pretty accurately determine how many tape drives are going to be required, how many slots, and calculates all the time required for the cleaning, for the consolidation, and all of that.